Hi, greetings and welcome to the first presentation from Qubit Quants. I'm your presenter Dilip. From the introduction video you might have seen earlier. In this presentation, I'll talk about the MetaTrader5 algorithmic trading bot infrastructure and the architecture elements. We built this algorithmic trading bot using the MetaTrader5 Python library. I'm sure, as you all know, MT5 has a native programming language called MQL5. But with this, there are some limitations, such as not being able to use any exogenous data sources. We only are stuck with this built-in backtester. And lastly, and most importantly, we don't have any possibility of using machine learning or neural networks in MQL5. And of course, machine learning and neural networks, we believe, when leveraged correctly, can take the performance of any strategy to a whole new level. Python is a popular package and has a vast array of libraries that make it a perfect choice for algorithmic trading, such as we have NumPy, which is built on C++ for fast array handling. Likewise, Pandas, especially designed for data analytics and tabular data processing. We have SciPy for statistical and scientific computations. And lastly, we have packages like scikit-learn, PyTorch, XGBoost, and TensorFlow for machine learning. So these are just some of the few reasons why we decided that Python was the go-to language of choice for building any algorithmic trading bot. As you can see, there are three main components to this trading bot architecture. First is this MT5PyBot module, which is comparable to an external physical form of a human being with various sense organs, or a PC system with various peripherals through which it interacts with the external world. The strategy module is comparable to the brains or the mind behind the operation, containing the main strategy and logic which generates the buy or sell signal. And lastly, we have this account monitor and data visualization dashboard, where we monitor floating data like the floating equity, floating P&L, current number of open positions, which are like live metrics. As well, we also analyze the performance of the strategy itself by looking at the closed positions in the order book history, basically historical trade data of the strategy. So the Venn diagram is used to showcase that the functions in a certain module are not exclusive just to that module, but all functions are floating in their utilization value and are commonly exchanged for utilization across modules. For example, we have this cloud data warehousing, which uses a cloud DB like MongoDB to store data related to the account monitoring and the order book history. And this data is then shared across all the three modules. So strategy, account monitor, MT5PyBot, they all access the MongoDB database and collections from time to time. So all functions are loosely coupled and have cross-module utilization. The MT5PyBot module contains many sets of functions which can be broadly grouped under the following 7 sections or categories. They essentially these categories cater to various requirements like data acquisition, order placement, order position management, alerts and notifications, order book access, cloud data warehousing, and logging functionality. I will dive deeper into each one of these components in the upcoming slides. So in the data acquisition section, we have the functions that deal with the acquisition of market price data. This could be like OHLCV data, open, high, low, close, volume, or tick data directly from the MT5 server. Of course, you can get tick data from other data vendors as well for your strategy needs. We also have various economic calendar events like the timings of various news releases or speeches by the Fed chair, Mr. Jerome Powell, which we acquire using this investpy.news Python library. And we haven't added functions for acquisition of economic indicators like CCI, PPI, or even sentiment data at the moment, but of course this is in the pipeline and it will be based on the requirements of the strategy. With sentiment data, you will be gathering data from Twitter or stock tweets or other social media feeds. The order placement section has functions that basically allows the placement of many different types of orders, with both immediate market orders as well as pending orders. Of course, before placing any order, we have to calculate the appropriate volume or lot size that corresponds to the defined risk. So we have this calculate lot size helper function. Thereafter, the order send functions will send the order request to the market or the exchange server at the given entry price, stop loss, and take profit, etc. And if the order was successfully sent, this evaluate result function will report the result to Telegram and also store it in the logger. As far as order position and management sections is concerned, this modify order function we have built handles the modification of entry price for pending orders and stop loss, take profit for both pending orders and open positions. There is also a close position function which exists to handle the full or partial closing of any open positions, or even we can also close by positions by symbol, like there is a news event coming that will affect a particular symbol and volatility is expected. You will just call this function and close all positions that were opened for that symbol. So these functions will allow for involved strategies to be coded where the risk and trade management rules are complex. This would involve like multi-step trailing stop losses, dynamic profit targets, volume reduction, or profit taking based off on multiple criteria, etc. Ultimately, we envision this will allow for adaptability to suit endless possibilities based on the strategy needs. And of course, as before, whenever we make modifications or partial closes, we report the result of the order send request to Telegram. So this order book access section basically contains the functions which are primarily useful for calculating the performance metrics and doing other analytics and data visualization. These include accessing the closed positions and deals from the order book history, generating a balance curve, etc. So in order for us to understand event failures and bug tracing in a live production environment, it is imperative to have a logger. So we have implemented this logging feature using this built-in logging module in Python to log all the raised exceptions or errors during the operation of the bot. So examples of these exceptions that you might encounter are like MT5 server connection failure, order modification request failed, etc. Of course, the logger will also log normal events like a trade closed based on the strategy rules at a set stop loss or take profit, etc. Ultimately, the goal of the logger is to help us in back tracing of events that led to failure or unknown behavior of the trading bot during a live deployment. And in order to be updated about alerts of various events and actions taken by the bot, we have configured this Telegram messenger bot to send messages to two different Telegram channels. One channel is for normal trade events, and the other is for like important or critical events, like say the bot is not functioning, server connection failure, or repeatedly some order request is getting failed, something like that. So the Telegram bot will send live notifications of new positions getting opened along with a snippet of a chart from the tradingview.com charting website. And it will also update about trade closures when it hits a stop loss and along with the net result in monetary value in profit or loss. For our data warehousing needs, we picked MongoDB as it has optimizations for storing time series data It has native support for creating WebSocket based data retrieval for database updates using this MongoDB change streams, and also it has built-in plotting options for plotting streaming time series data. So in MongoDB, we basically store all the data that is used for our performance metrics, analytics, and data visualization, such as the account history, the closed positions or deals history, as well as we store this live floating data, which is basically streaming in nature. These include the floating equity, P&L, number of open positions, etc. So all the various sections that I have just described till now have been coded in about 1700 lines of code in this MT5PyBot Python script. This was quite an effort spread over 2 months of development and then further 1 month of testing and debugging to rectify the mistakes and then finally we have it working in a satisfactory manner now. So this concludes section 1 of this presentation where I talk about MT5PyBot. In the forthcoming videos, we will talk about the other 2 sections, the strategy module and of course the account monitoring and data visualization dashboards. Thank you for your time and attention. If you have any questions, feedback, please leave them in the comments below and we will try to get back to you. If you like this video, please hit the like button to help the YouTube algorithms to promote this video, and if you haven't already, please subscribe to our channel and hit the bell icon to be notified of new video releases. Thank you again, bye and have a nice day.